Hello and welcome back to the online classes. In the previous video, we did displacement and distance from the chapter motion, right? Since no one commented or WhatsApp me anything, so I think you understood it, whatever I explained it to you. So in today's video, what we will learn is we will learn some physical quantities, right? Now, I've written down a definition of the physical quantities, okay? So, it is a physical property of material that can be measured and it has two types, okay? So, anything that you measure, say, suppose it may be height, the length, or the weight, right? Whatever you measure, these are all physical quantities. Now, physical quantities have two quantities. Physical quantities are of two types, and that is scalar quantity and vector quantity. Now we will learn about scalar quantity and vector quantity. Now scalar quantity. What is scalar quantity? Now I'll read the definition. It is a physical quantity having only magnitude and no direction. So it has only magnitude, right? It has only magnitude and no direction. So let me give you an example. Suppose my height. What is magnitude? My height, say suppose 6'8", right? My height is 6.8 feet. So this is the magnitude. This is the value of my height, right? Or the distance. Say suppose the distance from Ramagala to Namchi is 28 kilometers. So this is the value, right? So it has a fixed value. So anything that has value is magnitude. Yeah, you can tell it as magnitude, right? So I've given you some example, that is speed, distance, etc. These are some examples of scalar quantity. Now moving on to the next quantity, that is vector quantity. What is vector quantity? It is a physical quantity having both magnitude as well as direction. Now anything that has magnitude, this has magnitude but no direction, right? But anything that has magnitude as well as direction, we can call it as vector quantity. I'm going to give you an example. Say suppose I am going, so today I traveled 27 kilometers. So this is the magnitude, right? East. And this is the direction. Now this, I traveled 27 kilometers in the east direction. So that means this is a vector quantity. Sorry. This is a vector quantity. So anything that has magnitude, value, as well as direction, okay, we call it as vector quantity. So some of the examples of vector quantity are velocity, acceleration, displacement. Now in the previous video I have taught you about distance and displacement. Now you can differentiate, right? Distance is scalar quantity, whereas displacement is a vector. Okay, so now we will differentiate between distance and displacement. Fine. Now in the previous video I have already differentiated. Okay, I have already explained to you about distance and displacement, but still this point, the difference, this point is very important for exams as well. Okay, so in the previous years, this type of questions has come in your exam. So this is very important. You can copy this in your fair copy. Okay. Now, distance and displacement. The first point is it is the actual length traveled by an object. So distance is the actual length that is traveled by an object. And displacement, it is the shortest distance between the initial point and the final point. This I have already explained to you in the previous video. If you have not gone through that previous video, please go through it. Okay. Now the second point is it is a scalar quantity. Distance is a scalar quantity. As I have already said, it is a scalar quantity. It has only magnitude and no direction. Whereas displacement, it has magnitude as well as direction, right? Now distance, it is always positive and cannot be zero. So distance can never be zero and it is always positive, okay? Whereas displacement can be positive, negative, and can be zero. So now you can differentiate between distance and displacement. Now we will move on and differentiate between speed and velocity. We will do it in the same page so that you can easily differentiate between the speed and velocity, how they differ with each other. Now let us come to speed first. Now what is speed? So the distance traveled by a body per unit time. Okay, so it is a distance that is traveled by a body with reference to time. Okay, so mathematically it can be represented as speed equals to distance by time. Distance by time, which is this is, since there is distance here, so obviously it is a scalar quantity. So that means speed is a scalar quantity. That means it does not have direction, but it has only magnitude. Okay, so it is a scalar quantity. It is always positive and its SI unit. Now let us say, now we will derive SI unit from the mathematical formula. Okay, so the SI unit of distance is meter, right? SI unit of distance is meter and SI unit of time is second. So the SI unit for speed is meter per second. Okay, so this is for the speed. Now moving on to velocity. Now what is velocity? The distance traveled by a body per unit time in a given direction. Now velocity is a vector quantity since there is a direction. Okay, and speed is a scalar quantity because it only has magnitude, whereas it has magnitude. Velocity has magnitude as well as direction. So the distance traveled by a body per unit time in a given direction is velocity. So mathematically it is represented as velocity is equals to displacement by time. Okay, so it can be positive, negative and zero. Okay, it is a vector quantity as I already said. So since it is a vector quantity, so that means it can be positive, negative and zero. And the SI unit of velocity is as same as speed, that is meter per second, since the SI unit of displacement is also meter and the SI unit of time is second. So the SI unit of velocity is meter per second and this SI unit of speed is meter per second. Now you can easily differentiate between speed and velocity. Fine. And now moving on, we have average speed and average velocity. Okay, so how do we find average speed and average velocity? It has been already given in a book. So to find average speed, what we have is the total distance traveled by total time taken. Okay, so mathematically it can be represented as V equals to S by T, where V is average speed, time taken is represented by T and the distance traveled is represented by S. Okay, so and since it is speed, so the SI unit will always be meter per second, or you can write it as ms to the power minus 1. Okay, so these are the SI units. Okay, you can write in whichever way you want to write, both are correct. And average velocity. Okay, so average velocity is equals to the initial velocity plus final velocity divided by 2. So whatever the initial velocity is given, you add it with the final velocity and then just divide it by 2, you will get the average velocity. So mathematically it is represented as V equals to V average equals to velocity average equals to initial velocity plus final velocity divided by 2. So this is very easy. Okay, now I want you to go through the book once again. Okay, read each and every part of the book. Sorry, read through in the chapter motion. Read. So now I think you understood what is average velocity and average speed, right? Now what I want you to do is you go through the book once again, just go through this video and the previous video, and then if you don't understand it, okay, you can just ask me, and it would be better if you solve one or two questions from the example in your fair copy. And what I want you to do is, I want whatever I explained to you, whatever I have definition that I had written, or okay, whatever I have done today, I want you to do it in your fair copy in a good handwriting. Fine. And so by saying this, I would like to end my video for today. Okay, we will meet in the next video. So until then, please go through your books. Okay, since it is hard for all of us, so you must stay prepared at home. Okay, so please go through the book, not only science but maths as well, or and any other subjects. Okay, please go through it so that you stay updated with your books. Okay, and this holiday, it doesn't affect your studies. Okay, so thank you very much.